Okay, in this video we're going to look at how to determine what the tan graph looks like. Well, we've mentioned before that tan equals sine over cos. So that should have been something you learned in grade 11. You can look at that. And it also equals y over x. Okay, so tan theta equals y over x and equals sine theta over cos theta. That's an identity right here. So this is an identity that you learned in grade 11. You can check it out. It's very easy to prove. Just write in what sine theta equals in terms of x, y, and r, and what cos theta equals in terms of x, y, and r, and that works out. All right, so if tan theta equals sine theta over cos theta, well, all we need to do is look at the two graphs. This is a rational function. So this rational function equals 0 when the top equals 0 and the bottom doesn't. And this rational function has vertical asymptotes when the bottom equals 0. Okay, so when cosine equals 0. So we can look at these two functions graphed together. So here's the sine function, and here's the cosine function, which we just saw earlier. So if we graph them by a quarter of a period, it makes it nice, and then a quarter of that, so an eighth of a period, you can see these intersection points. All right, so at 0, tan of theta equals sine theta over cos theta. Sine theta equals 0, so this becomes 0. Okay, so if you want to look at this graph compared to this one, okay, so this is going to be the tan graph, and I'm doing it from this one here. Okay, so tan theta equals this graph over this one. At pi over 4, they're the same value. So tan theta must equal 1. So when you divide a number by itself, you get 1. At pi over 2, well, sine theta equals 1 and tan theta equals 0. So we get a vertical asymptote because you can't have the denominator equal to 0. It's undefined. So we get a vertical asymptote at pi over 2. Same thing at 3 pi over 2. Okay? Now at 3 pi over 4, sine theta equals almost the same as cos theta. They're just negative each other. So when you divide two numbers by themselves, but one of them's negative, then you get a negative 1. So you get this point down here. Okay? And then at pi, well, sine theta equals 0, cos theta equals negative 1. 0 over negative 1 equals 0. Plot that. And at 5 pi over 4, they're the same values. They're both negative. So you divide them, you get 1. Okay? And so on. And when you join those together, you get this nice graph. Okay? Doesn't look hardly anything like the sine or cosine graph. And when you look at this, you notice that the pattern is a little bit shorter. So here is one cycle between these two asymptotes. Or if you just look at from the beginning to there, from 0 to pi, it repeats itself on this side. Same thing. So the period of this one, which we call t, is equal to pi. And when you want to graph tan k theta, well, k is just pi over the period. So this is a formula that you should be familiar with from using degrees, but instead of 180 degrees, we've got pi radians. Okay, so that's the tan graph. Now you could get the same graph from using the circle. Now it could be a unit circle. It doesn't have to be a unit circle for this one though, because we're not mapping across x or y in this case. So it would just be a circle of radius r. And if we're looking at every pi over 4 radians, then at 0, tan theta equals y over x. Y is 0 there. X is r. Okay, the radius of the circle. Okay, so r, negative r, negative r. So we get the point 0, which is there. When we go up to pi over 4, well, at pi over 4, these two angles are the same. So these two sides are the same. So y over x, because y equals x, is just going to be 1. So at pi over 4, tan theta equals 1. And then at pi over 2, well, tan is y over x. Y is r, so the y coordinate of that point is r, but the x coordinate of that point is 0. So r divided by 0, y over x, is undefined. So we get this vertical asymptote. And you can keep going around this circle, doing the same thing, and you'll get all these key points on the tan graph. And then you've got a nice graph of tan. Okay, so you can get it either from the two graphs, sine and cos, or from a circle that could be a unit circle, but it doesn't have to be any circle radius r. And you could use any circle radius r for the other two graphs too, just the unit circle is most convenient. Okay. Now that's the tan graph.